Questions 21 to 25 of the 1999 Grade 9 Pascal Math Contest. A number is B-presque if it is the only natural number between a prime number and a perfect square. So for example, 10 is B-presque, but 12 is not. The number of two-digit B-presque numbers, including 10, is. So the first thing I want to do is explain this question before we tackle it. So we'll write a perfect square. So let's say 9. And we'll write a prime number that's near it. So for example, 11. And what number is in between? Well, obviously it's 10. And therefore, because 9 is a perfect square and 11 is a prime number and 10 is the only natural number between the prime number and the perfect square, that number is B-presque. All right? And they even gave you that as an example to help you understand. So we have to find how many of these B-presque numbers are there. But they made our life a little easier by saying only the two-digit ones. So we only have to worry about numbers between 10 and 99. All right? So the first thing I'm going to do is write out all the perfect squares between, let's say, 9 all the way to 100. So we've got 9, 16, 25, 36, 49, 64, 81, and finally 100. All right? And now I'm going to write inside or in the middle the prime numbers. So this is one of those questions where memorizing the prime numbers from 2 to 100 is obviously very important because they're not giving you a list. So we've got 11, 13, 17, 19, and 23. We've got 29 and 31 over here. 37, 41, 43, and 47 over here. We've got 53, 59, and 61. And 67, 71, 73, and 79, and finally 83, 89, and 97. All right, so now what we have to do is see if this scenario exists anywhere. Well, the first one we know is right here, is 10. 10 is the only natural number between a prime and a perfect square. So in this case, our prime is 11 and our perfect square is 9. So let's go to the next one, 13 and 16. Is there only one number between 13 and 16? And the answer is no. How about 16 and 17? Well, there's no number. There's no natural number in between those two because those are consecutive. How about 23 and 25? Yes, there is one number in between there. So that 24 is a B-presque number. Great, we found our second one. 25 and 29, there's more than one number in between those, so that scenario will not satisfy our conditions. 31 and 36, several numbers in between there. 36 and 37 are consecutive numbers, so that's not going to help. 47 and 49, there you go. We've got only one number in between there, and therefore it is B-presque. One number between a perfect square, namely 49, and a prime number, namely 47. Let's keep going here. 61 and 64, we've got a couple numbers in between there. 64 and 67, you've got a couple numbers in between there. 79 and 81, you've got only one number, so that's an B-presque number. 81 and 83, another one, only one number between this perfect square and this prime number, and therefore that is a B-presque number. And finally, 97 and 100, there's two numbers in between there. So the total number of two-digit B-presque numbers, we've got 1, 2, 3, 4, 5. So the answer is E. If W equals 2 to the power of 129 times 3 to the power of 81 times 5 to the power of 128, x is equal to that, y is equal to this, and z is equal to that, then the order from smallest to largest, oh boy. So the terrible way of doing this question is to expand all these and make these massive numbers and then compare them. And fortunately, there is a shortcut. And you can probably figure out the shortcut once I write these numbers out side by side, or aligned with each other. Just take a look at the numbers and see they're all very similar. Y is 2 to the 126 times 3 to the 82 times 5 to the 128. And finally, we've got 125, 82, and 129. Do you see something common? They're all very similar, so if we can factor out what is similar, then what is remaining can be compared much easier. So if I'm going to factor out the highest possible, I'm going to factor out 2 to the 125, because that can be factored from all of them. For power of 3, I think I can factor out 81. And for a factor of 5, I can factor out 128. All right, from all of these. So what remains for W is 2 to the power of 4. And that's it. What remains for X, if I factor out 2 to the power of 125, 3 to the power of 81, and 5 to the power of 128? It looks like 2 to the power of 2, and that's also it. All right, so that's very, very helpful. Similarly, I factor out this big long number from y, and I get 2 to the power of 1, but I also get 3 to the power of 1. And then finally, from z, if I factor this out, I've got, let's see, 3 to the power of 1 and 5 to the power of 1. All right. So these are all the same. So the only thing we need to look at are these ones. So this is 2 to the power of 4, which is 16. This is 2 to the power of 2, which is 4. This is 2 times 3, which is 6. And this is 3 times 5, which is 15. So we can easily see what is the smallest and what is the largest. The smallest, of course, is X, right here. Next in line would be Y, and then Z, and then finally W, from smallest to largest. And of the answers, that would be choice X, Y, Z, W is C right here. Al and Bert must arrive at a town 22.5 kilometers away. They have one bicycle between them and must arrive at the same time. Bert sets out riding at 8 kilometers an hour, leaves his bicycle, and then walks 5 kilometers an hour. Al walks at 4 kilometers an hour, reaches the bicycle, and then rides the bicycle at 10 kilometers an hour. For how many minutes was the bicycle not in motion? All right, so a lot has to be explained here. So first, they start off here, let's say starting point, and they're going to some town. And that town is 22.5 kilometers away. Okay? So that's the first part. And then let's draw Bert in his scenario. He first starts here, and he rides his bicycle to a certain point. And it is 8 kilometers per hour that he's riding this bike. We'll write down bike right here. And then at this point, he leaves his bicycle right here. Leaves bike. He just drops it. And then he starts walking all the way to the town. And he walks at 5 kilometers an hour. Like that. And we'll write walk. Okay, so that's Bert and his journey. Now we've got Al. Al also starts at the same place, but he walks initially until he reaches that bike. So he's walking, and his speed is 4 kilometers per hour. And then Al will jump on the bicycle that Bert left for him, and then Al will ride that bike all the way to the town. And his speed, he's riding the bike a bit faster, so 10 kilometers per hour. All right, so I hope you understand the question first before I start getting into X's and Y's and all this stuff. Okay, so here we go. Now, Bert, we need to figure out what is the distance that he bikes. Now, we don't know, so I'm just going to call that distance, let's just call it X. Okay? So that means 8 kilometers in 1 hour, that's the speed, will be the same as X kilometers over his time. And in particular, T1. T1 is from start to the point that he leaves his bike. All right? And then similarly, we need to do the same thing for when he was walking. 5 kilometers in 1 hour will be the same as, what is his distance from here to here? Well, the full distance was 22.5. So if this is X, this will be 22.5 minus X, the distance. 22.5 minus X. All over T2, because T2 represents the time from here to here, from the time that he leaves the bike to the time he reaches the town. All right? Nothing fancy. Now we get to Al, same story. For him, it's 4 kilometers in 1 hour. And the distance is the same, right? Because he's starting at the same point and he walks until the same point where the bike is left. So that's X. But the time, we need to write a different variable, so we write T3. The time that it takes Al to walk from the start to the point where the bike has been left, this point. And then from this journey, we can get the following equation. 10 kilometers in 1 hour is the same thing, 22.5 minus X over T4. All right? Now both of them arrive at the town at the same time. So Bert's times T1 plus T2 have to be the same as Al's time, T4 plus T3, right? Because they both arrive at the same time. So let's substitute into this equation what we got from these equations. So T1 from here looks like X over 8. And T2 from here is 22.5 minus X over 5. And then T3 from here is X over 4. And T4 from here is 22.5 minus x over 10. Okay, so now we have to solve all of these. So we've got x over 8 plus, try to find a common denominator here, like that, and then 2x over 8. I'm doing a common denominator, so when I add or subtract, I'll be able to do that, and like this. So bring this over to the other side and subtract. You'll get just 22.5x minus x over 10, and this to the other side will give you x over 8. And therefore 10x cross multiply is 180. 8 times 22.5 minus 8x, and therefore 18x is equal to 180, and x is equal to 10. All right, so we figured out the distance, which is 10. This distance right here, from here to here, is 10. Now we're interested in the times. So we have to figure out T1, T2, T3, all that stuff. So T1, if you remember, right here, is x over 8. So 10 over 8, which is 1.25. T2 is 22.5 minus x over 8, which is 12.5 over 5, which is 2.5. All right? And then T3 is x over 4, which is 10 over 4, which is 2.5. And finally, T4 is 22.5 minus x over 10, which looks like 12.5 over 10, which is 1.25. All right, so we've got all the time, and we can now figure out what they're asking. Go back and review what they're asking. For how many minutes was the bicycle not in motion? So let's understand what they mean by that. So when this first journey began, Bert rode his bike from the start to this point. Then he left his bike, and then the bike was just sitting there, not in motion, until Al reaches it. When he reaches it, he jumps on the bike, and the bike starts in motion again. So we have to figure out how much time was the bike just sitting there. Well, how much time did it take Bert to go from S to the point where he leaves the bike? That was represented by T1. And T1 we calculated as 1.25, correct? 1.25. And then he starts walking. The bike is sitting there now. And Al is then walking towards the bike. His time was represented along this part of the journey as T3. And what is T3? We calculated that as 2.5. So T3 is 2.5. So think about it. The first 1.25 hours, the bike is in use and Al is walking. Bert leaves the bike, starts walking, and the bike is not in motion until Al gets there. And when does he get there? After 1.25 hours. So the first 1.25 hours, if this is 1.25, Al is walking, but this bike is being used by Bert. Right? That's what T1 is. And then the next 1.25 The bike is just sitting there waiting for Al because it takes him a full 2.5 hours to get to the bike. So the amount of time that the bike was not in motion is 1.25. Okay? And that's in hours. So we have to convert 1.25 into minutes. And you do that just by multiplying by 60. So this becomes 75 minutes. So the answer is B. A number is formed using the digits 1, 2, all the way up to 9. Any digit can be used more than once, but adjacent digits cannot be the same. Once a pair of adjacent digits has occurred, that pair in that order cannot be used again. How many digits are in the largest such number? So, let's first explain what's going on. You've got all these numbers, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you can use any of these numbers to form a big long number. But there are certain rules. Adjacent digits can't be the same, so you can't put anywhere in the number the same digits side by side. You can't put 8, 8, 9, 9, 7, 7. You get the idea. Not allowed. And then once you do create the number 5, 6, whatever, 7, 2, once you create a pair of adjacent digits like that, that pair can never occur again. So you can't then go on and put 5, 6 again. All right? So let's go with this. We want the largest such number. All right? So if we want the largest such number, we want to start with a 9 because the 9 will give us the largest such number. So now let's move forward with our rules. What's the next number? Well, we're concentrating on making this number the largest possible. So let's make the next one a 9. But we can't because adjacent digits cannot be the same. All right, so it cannot be a 9. Can it be an 8? Sure. It can be an 8. Now let's go for the third digit. Again, we want it to be the largest number, so can we put a 9? Yes, we can. Now the next digit, can it be a 9? No, because adjacent digits cannot be the same. Can it be an 8? Can I put an 8 in here? No, because remember, once a pair of adjacent digits has occurred, that pair in that order cannot be used again. So since 9, 8 has already occurred, I cannot put 9, 8 again. So therefore, 9, 8 cannot be done. All right? So the most I can put in this fourth digit is a 7. All right, so I hope so far that makes sense. Let's keep going. Can I put a 9? Yes. Now, can I put a 9? No. Can I put an 8? No. Can I put a 7? No, because same story. If I put a 7 in here, it'll be 9, 7, and I can't. So the most I can put is 6. And similarly, if you keep doing this, you'll get this kind of a pattern. 9, 4, 9, 3, 9, 2, and 9, 1. All right? And then now we've exhausted the 9s. Now we get on to 8. This number is continuing, by the way. I don't have any space left on this side, so I'll start writing it on this line. How about the next digit after the 8? Can I put a 9? No. Why? Because the 8, 9 is already represented there. Can I put an 8? No, because adjacent digits cannot be the same. But I can put a 7, I hope. And I believe we can. And similarly, for the 8s, it becomes this kind of a story. 8, 5, 8, 4, 8, 3, 8, 2, and 8, 1. All right? So I hope you understand what's happening. Let's just keep going here because I really want you to understand it. I want you to understand it because I know that you can. A lot of times on these contests, people get discouraged. They read the question and they think, oh, I don't know how to do it. but you absolutely can if you just take it slow and understand the question. Now we get to sevens. Can I put a 7, 9? Nope, because 7, 9's already been used. Can I put a 7, 8? No, because 7, 8's already been used. Can I put a 7, 7? No, because adjacent digits cannot be the same. So I can only put a 7, 6. So the sevens have this type of a story. All right? And similarly, I hope by now you kind of get the pattern. This is what's happening. And then the fives would be 5, 4, 5, 3, 5, 2, 5, 1. Fours would give you 4, 3, 4, 2, 4, 1. Threes would give you 3, 2, 3, 1. And then twos, I believe there's only 2, 1. And then I think there, after this point, you can keep going by putting another 9, right? You can't put a 1 or a 0 because there is no 0. There's no 10. So you can only put a 9. And then you can't put anything after that because 9, 8 has already been used, 9, 7. So that's it. So how many digits? That's what they're asking. Okay, we can add up the digits. That shouldn't be so hard. How many digits are there in that first line? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 digits. Next one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think that goes down by 2 every time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, I was right. So this is 10. This is 8. This is 6. This is 4, 2, and 1. So we have to add up all of these. 16 plus 14 plus 12 plus 10 plus 8 plus 6 plus 4 plus 2 plus 1 is 73. Yeah. Okay, so the largest such number has 73 digits. This is a very good question. I like this question because if you understand it, you can do it. It just takes a little bit of patience and a little bit of confidence. So don't get discouraged. All right, number 25. Two circles C1 and C2 touch each other externally, and the line L is a common tangent. The line M is parallel to L and touches two circles C1 and C3. The three circles are mutually tangent, so right there. If the radius of C2 is 9 and the radius of C3 is 4, what is the radius of C1? So let's draw this out bigger. Okay, so that's pretty good. Now let's start drawing the centers and start connecting things to help us figure out the radius of C1. So the center of C1 to the tangent point right there, and similarly the center of C3 to the tangent point, it's going to be a straight line. Similarly, the center of C2 to the tangent point, through the tangent point to the center of C1, and C3 to C2, like that. Okay? And then we need to draw some perpendiculars. So all the way down here like that. That one. And this one down here. And then I'm going to connect this triangle and this triangle right here. All right, so let's go with this. So at this point that we have our circles and our lines drawn, we need to of course start labeling this. So for C1, that is what we need to figure out. So we don't know, so we'll call it R. So this is R from here to here. And then similarly, if that is R, then this circle, C3, will also have radiuses labeled, and C3 they've given us is 4. So this is 4 from here to here. And therefore that's 4, and that's 4. And then for C2, they've also given us the radius is 9, so this is 9. This is 9 down here, and therefore this is 9 right here. And then this is also R, the radius that we are trying to figure out. The way I drew this is to make this a right angle, and therefore if this is 9, then this is 9 right here, since it's exactly opposite. And then this little guy in here is going to be what? R minus 9, right? Because from the center till the tangent point is R, and then this is 9, so we need to subtract that. And then similarly on the top, I drew this to make this a right angle, and since this is 4, this is also 4, and therefore this part right here will be R minus 4. This part right here. Okay, so I hope that makes sense, and if it does, I can move this up. So now we are going to have hopefully some mathematical formulas that we can use. And before I write out the relationships that Pythagoras is giving us, I need to label two more things. I need to label this distance here, from here to here, and I'll call that x, and therefore from here to here is x. And I need to label this distance here, which I will call y, and therefore this is y as well. Alright, so let's figure out our first relationship, and which triangle are we going to use? Well, whichever one you want. I'll just start with this one here, this triangle in here. I'll use Pythagoras on that one. So I'll have r minus 9 squared plus x squared is equal to r plus 9 squared. Okay, so this gives us r squared minus 18r plus 81 plus x squared is equal to r squared plus 18r plus 81. And therefore, this looks like the r squares cancel, x squared is by itself, and this plus that is 36r, and the 81's cancel. Great. So x is going to be 6 root r. Okay? Now very similarly, I will do Pythagoras on this triangle right here. That one. And that will give us r minus 4 squared plus y squared is equal to r plus 4 squared. And let's move this all the way up. So this gives us r squared minus 8r plus 16 plus y squared is equal to r squared plus 8r plus 16. Y squared by itself, the r's cancel, the 16's cancel, and this becomes 16r, and therefore y is equal to 4 root r. So we've got some good numbers here, and this is going to help us. Now we have to figure out r. So which triangle do we use? Well, that triangle, save the best for last, is this one right here. Drop a perpendicular from that point down to here, and this becomes a right angle. So from here to here is what? Well, if I continue to drop that perpendicular, I'll get down to here, and you'll notice that from here to here is y, and from here to here is x. So this in here is x minus y. Okay? And then what about this part here? This part. Well, that part is this plus that. Correct? So r minus 4 plus r minus 9. So let's circle that in red to make it stand out there. This part in here. And this was x minus y, right? And then finally, the hypotenuse of this triangle is 4 plus 9. Okay? So we've got this triangle, and hopefully this will give us the value for r. So let's do this. So I'll draw that triangle out a little bit so that you don't get confused. Remember, this was x minus y. This side was r minus 4 plus r minus 9. And this side was 4 plus 13. So we're going to do Pythagoras on this. So we have r minus 4 plus r minus 9 all squared. X minus y all squared equals 4 plus 9 all squared. All right, don't make any mistakes. I think I made one and I had to erase it. That's some of the biggest problems, making these little tiny errors. All right, so this simplifies to 2r minus 13 all squared, and then x minus y. Well, x and y we can substitute. That was the whole point of this big long calculation up here. X is 6 root r, and y is 4 root r. Okay? So we got everything in terms of r, so that's great. And then this is, of course, 13 squared, which is 169. So now we got 4r squared minus 52r plus 169. And then this is 6 root r minus 4 root r is 2 root r. So like this. All squared is equal to 169. All right, things are starting to happen here for us. The 169's cancel. This becomes 4r, like that. And then 4r squared minus 52 plus 4 is minus 48. And then factor out a 4 and you'll get r squared minus 12r. And then factor out the r and you'll get r minus 12. And there you go. R, therefore, minus 12 is equal to 0. R is equal to 12. Great. And that is indeed the answer. And of the answer choices, that would be 25 is D.